We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello students, today I am going to discuss about the topic estimating and costing that is related with semester 6 of BE production program. Now today we will discuss about machining time calculation in turning operation. For that we need 3 data, that is cutting speed, second is feed, and third one is depth of cut. So we need 3 data basically and other data. So to understand this, take an example that here we have a round piece of a material or metal and its initial diameter d1 equal to 30 mm, and we want to reduce it up to d2 equal to 25 mm in one cut. Suppose we are given data that is cutting speed is 30 minute per meter. Sorry, it is meter per minute, and feed is 0.4 revolution per minute, and the length is 100 centimeter. Sorry, it is mm. So L equal to 100 mm. Now we have the equation to find machining time Tm equal to L upon Fn. Here L is length of workspace, that is 100 mm. F, that is feed, it is given as 0.4 revolution per minute, and N RPM of workpiece. So in this data RPM is not given, so we will find RPM by using equation V equal to pi equal to D equal to N upon 1000. So here N equal to V into 1000 upon pi into D equal to 30, 1000, 3.14, and initial diameter, that is 30. So roughly this answer is 318. So that is the value of N RPM. So now by using our standard equation we can determine the machining time, that is Tm equal to L upon Fn. So here L equal to 100 mm, F that is 0.4, and N that is 318. So our machining time is 0.79 minute, that is Tm. So in this calculation we have considered only one cut, but many times there is a restriction of depth of cut. So we have to turn by taking either 2 or 3 cut. So if there is a 2 cut, we have to multiply by 2. That is number of cuts. So by this way we can calculate the machining time of any turning operation of the piece of any material. So here we can also add into this L, that is here L equal to small l plus A plus O. Now what is A? Suppose the tool will be here at initial position. So to engage the tool to material, they have to travel some distance, and that is known as A, that is approach length. And after finishing the cut, tool will move up to here. So this distance is known as O, means over travel. So to find out the value of machining time, we have to consider of approach length and over travel length also. So if it is not given, you can neglect it or you can assume it. So you can try the example by taking different dimensions and you can do practice. Thank you very much, students.